everyone, welcome to the study of second order differential equation, nonlinear part. So this equation consists of two parts. It has the particular part and the complementary part. So for the complementary part, the reduced form will be y double prime minus 3y prime plus 2y, which is equal to 0. So to solve this, we let our y to be exponential mx. We differentiate y once to get m exponential mx, and we differentiate y twice to get y double prime, which is equal to m squared exponential mx. From that, now we substitute our value here so that we will have m squared minus 3m plus 2 into bracket y is exponential mx is equal to 0. You note that exponential mx cannot be equal to 0, meaning that m squared minus 3m plus 2 is the one which is equal to 0. This is a quadratic which can be factored as m squared minus m minus 2m plus 2, which is equal to 0. M into bracket m minus 1, close the bracket, minus 2 into bracket m plus minus 1 is equal to 0. So m minus 2, m minus 1 is equal to 0, meaning that our m1 is equal to 1 and our m2 is equal to 2. So our complementary part becomes c1 exponential x plus c2 exponential 2x. Now to solve our y particular, we are going to employ the following procedure. We will write it in symbolic form, which is d squared minus 3d plus 2 into bracket y. This is equal to exponential x cos of x. Then yp is equal to exponential x cos of x divided by fd, which is equal to exponential x cos of x over f of bracket d plus a. Which is equal to exponential x cos of x into bracket f of bracket d squared minus 3d plus 2. So yp can be written as exponential x cos of x divided by, so you have d, one with is the part there in exponential x minus 3 into bracket d plus 1, then plus 2, which is equal to exponential x cos of x divided by d squared, this is squared, d squared plus 2d plus 1 minus 3d minus 3 plus 2. So yp is equal to, so we simplify this, exponential x cos of x divided by d squared. You have 2d minus 3d, which will give you minus d. You have 1, and this other part here, so that will give you 0, which is equal to x squared cos of x divided by where you have d, d squared we substitute it with negative 1 squared minus d. This is equal to exponential x cos of x divided by minus d minus 1. So yp is equal to minus d plus 1 exponential x cos of x divided by minus d plus 1 multiplied by minus d minus 1. This is equal to exponential x into bracket minus d plus 1 cos of x. We close that bracket divided by, this will be d squared minus 1. So yp is equal to exponential x into bracket. D means we differentiate, so we will have sine of x. Negative and negative will cancel, plus cos of x, close the bracket, divided by 1 squared minus 1. So yp is equal to negative 1 over 2 exponential x into bracket sine of x plus cos of x. So our solution, y will be given by y of c plus y of p, which is equal to c1 exponential x plus c2 exponential 2x minus 1 over 2 exponential x into bracket sine of x plus cos of x. So that is our solution of our given ODE by use of the method of inverse D operator. Thanks so much. For more such learning, tune on to my YouTube channel so that we may continue learning together.